Hey everyone, thanks for checking out my data visualization final project. For this assignment, I created a poem visualizer. This website is designed to provide a novel way of exploring poetry and other forms of text. It uses NLP techniques to convert the input text into word vectors and then constructs various visualizations based on those vectors. The aim of this project is to offer a tool that can help artists understand their poetry better, and also help computer scientists learn more about Word2Vec and its applications. I obtained the word vectors from a pre-trained model called GloVe, which was created here at Stanford. The researchers created these word vectors using an unsupervised model that looks at the frequencies with which each word appears next to other words on Wikipedia, and groups them based on these similarities. Through a process of PCA, principal component analysis, these 50-dimensional word vectors were converted to 2 dimensions for the purpose of visualizing. So how exactly do you use this program? First, input your text selection into the large text input section in the top left of the web page, or click on the click here to autofill a random popular poem or other chunk of text. The large square in the top right is where your poem will be visualized. Here, once you click the large visualize button in the bottom right of the screen, you will see a point for each word in your poem, as well as a line that shows the trajectory of the poem over time. Hover over various points to see which word they correspond to. In the trends section, you can input up to 9 words that can be used to show trends throughout the poem. Either type a word into this box and press enter, and you'll see the word appear in the graph up here, or click the cursor icon to directly interact with the poem graph and add the closest word to where you just clicked. To stop tracking a trend word, simply click on it. The long rectangle in the middle of the website is the trend visualizer. Each column represents one word from the poem in the order presented in the poem, and each line represents the similarity of a trend word to the poem over time. The similarity is computed as the distance between the trend word and each poem word, and the lines are color-coded for each trend word. The more similar the 2 words are, the closer the line will be to the top. You can also switch between Euclidean distance and cosine distance using these buttons up here. By hovering over one column, the corresponding word will be displayed in the top left of the rectangle, and the corresponding point in the poem visualization will be highlighted. Notice that the rectangle will also be highlighted when that point is hovered over. Here are some examples of it working. Here's "O Captain, My Captain" by Walt Whitman. Here's "The Road Not Taken" by Robert Frost. Here's "She Walks in Beauty" by Lord Byron. Here's "Shall I Compare Thee to a Summer's Day" by William Shakespeare. And here's "Do Not Go Gentle Into That Good Night" by Dylan Thomas. Was this a good idea? What are these graphs even showing? I won't lie, this program didn't work as well as I'd hoped, or at least it didn't work how I expected. One major oversight I had when conjuring up this idea was that words from popular poems will probably end up very condensed, because these words tend to appear next to each other a fair amount. It's not like poems are just a string of randomly selected words. They use common grammar a lot of the time, so the visualization usually ends up looking like one of these dense clusters with a few random points for the less common words. Take a look at this poem, "Light of a Candle." The visualization isn't particularly interesting because most of the words are right next to each other. However, "The Road Not Taken" fares a little bit better because it has some more spread out words. This list of my best friends' names does really well since they're surprisingly diverse in the feature space. This list of states is interesting because they're all right next to each other, except for some notable exceptions like New, North, South, West, Island, Washington, which all makes sense when you think about it. This visualization is also kind of a straw man representation of word vectors, since we're only visualizing 2 dimensions when oftentimes word vectors can have upwards of 300 dimensions. A 300-dimension word vector visualizer would be much more interesting, but until we have web browsers in 300 dimensions, we're stuck with this. Who would even use this? Artists maybe, computer scientists. It could be used to try to better understand word vectors and get a better intuition for what they're quantizing. But honestly, I think this program is mostly just to be used for fun. Like, put in your name and your significant other's name and see how close you are. Put in a funny quote and see if it draws a cool picture. Try to come up with a poem that means something but also draws something funny. The possibilities are endless. It's definitely more of an artistic and abstract approach to visualization than most of this class was, but I think there's something beautiful in the absurdity of all of it. One of the greatest parts of this program is clicking around randomly to see what words you can find. Something about finding really weird words in the dataset is just pretty amusing to me. Something I learned from Go Wong this year is that one of the most important qualities of artists is that we make things that wouldn't have otherwise been made. I think this might be one of those things. Anyways, thanks for watching.